Good afternoon and welcome to this webinar from the Institution of Mechanical Engineers on adapting industry to withstand rising temperatures and future heat waves. My name is Dr. Tim Fox and I was lead author of our recently published report on the topic, and I'll be presenting the work along with co-author Dr. Laura Kent. Following the presentation, we'll be joined by Ruth Shilston, Professor John Dora and Dr. Carola Koenig, all of whom made substantial contributions to the report. John Dora in the area of standards and engineering codes, Ruth Shilston in the area of building, the built environment and industrial buildings, and Dr. Carola Koenig on education and the need to adapt curricula to meet the future challenges of climate change and in particular heat waves. They'll be joining me for a panel discussion in response to your questions. And in that regard, please do use the Q&A function to ask questions during the presentation. And I'll then address these to the panel afterwards. So let me give you some background to the piece of work that I'm about to describe. So the project that sits behind the report that we published a couple of weeks ago on April the 26th commenced in January 2022, and the work was driven forward and led by the Process Industries Division Board, part of the institution, and it was stimulated by the heat dome event that occurred in Western Canada in 2021, the summer before we began the work. In addition to Process Industries Division, we had contributions from a wide range of IMechE members across a number of boards and from the divisions and groups. And we had external subject matter experts involved in the development of the work. And these came from the UK, Canada, Greece, and India. So covering a wide range of geographies, industrial sectors, and as well as academia and government agencies. So the ultimate output of the report, of the work, was a technical report, which covered the project findings, and I'm going to walk through some of those during the course of this webinar alongside my colleague Dr. Laura Kent. And we provide recommendations for industry policymakers and the engineering profession, and indeed academia both in a UK context and an international context. So this webinar forms part of the dissemination activities of the project. So let's begin with a fairly strong statement from the Intergovernmental Panel on Climate Change. This comes from the 2021 report, the Assessment Report 6, so the latest climate assessment from the IPCC. And from the physical science basis, the first report they published in the 3-report series. And the statement's fairly clear. It's unequivocal that human influence has warmed the atmosphere, ocean and land. And indeed, the world is getting hotter. And we're provided with evidence from all around us in endless numbers of reports from scientific community coming out saying that the climate is warming up right across the globe, and that it's having significant impacts. And if we look at events in recent years, overall, there's a shift to warmer seasonal ambient temperatures throughout the year, so warmer winters and hotter summers, and an increase in the frequency, duration, and severity of heat waves. And indeed, if you think back to the summer of 2021, which stimulated this piece of work, not only was there the heat dome effect in Canada, leading to a national high of 49.6 degrees C in Linton, British Columbia, really just touching just below 50 degrees C, but also unprecedented heat waves across Europe, including in Greece, which reached 46.3 degrees in multiple cities. So this was followed, of course, last year here in the UK by a significant and record-breaking heat wave that really did generate a lot of concern, particularly in the media, where we saw a high of 40.3 degrees C set. And then, of course, at the same time, across the rest of the world, heat waves were occurring, and one example, of course, being in China, where they experienced an unbelievable 70 days in a row with temperatures in excess of 40 degrees C, affecting more than 900 million people, and of course, significant impacts on the Chinese way of life and economic productivity. And of course, this year's got off to a similar start. We started the year at the turn of the year, just after Christmas and into the new year, with Europe beginning with a unprecedented warm period. We've seen heat waves through the early spring, through March in South America. And more recently, you'll remember a few weeks ago, there was a substantial heat wave across Asia, both the Asian subcontinent of India and across Southeast Asia. So the world is undoubtedly getting hotter, and this leads to a lot of challenges for industry in terms of how it's going to adapt to those increasing ambient temperatures and how it's going to adapt to those heat waves. And that's really the topic of the rest of this webinar. So I'm going to hand over to my colleague, Laura Kent, who's going to talk a little bit about the human impacts aspects of the work. Over to you, Laura.
Thank you, Tim. So put really simply, heat is going to start to impact on productivity, not just in the UK, but globally. And we are already starting to see high losses in productivity, with that due to increase as temperatures start to increase. So in 2020, losses across 12 global cities amounted to 44 billion. And it's predicted by 2050 that will rise to 84 billion if emissions are not addressed. So these productivity impacts often land on those that are least able to bear it, and also start to impact our individual incomes. In part, this is because there's a reaction to heat stress. People move slower to conserve effort and energy, but also they're more prone to making mistakes and start to have reduced decision-making abilities. And it does become an occupational health risk. So, for example, PPE may not be worn properly, just because it's so hot. You might be more tempted to not put it on properly or wear the full amount. And obviously there's impacts there, but taking it further beyond 38 degrees, you can start to see heat exhaustion. And beyond that, you start to see cases of heat stroke, which can be fatal in the worst cases. It's also important that we consider some of the mental health impacts of increased heat and what that does to our well-being. So in Italy last summer, employees dragged down tools in an automotive manufacturing facility because the indoor temperature was unacceptable. And it's likely that we could see similar situations as temperatures do start to increase. A first step should be that an implementation of administrative measures and just raise awareness of the importance of regular breaks and sufficient hydration, just to make sure that the workforce is healthier, safer, and a more productive workforce. And on that note, I'll hand back to Tim.
Thank you, Laura. So moving on to the physical aspects of industry. So thinking about industrial assets such as plant and machinery, and then thinking more broadly around buildings and infrastructure that supports those industries. The report focused on a broad range of industries that essentially underpin the economic growth and well-being of all nations worldwide, both developed and developing. So many of these industries have processes that are temperature dependent, either that provide feedstocks or finished products into other feedstocks into other industries or finished products for market. And the application of heat in these industries is really important to their ability to function. And the control of temperature can be absolutely critical to the fundamental operations of the facilities. So we're thinking here about industries such as those that are involved in producing chemicals or processing raw materials into feedstocks or into finished products for marketplaces. We're thinking in industries that are involved in energy production of one form or another. So we looked at the oil and gas industry. We looked at the biofuels and production industry, and industries that are involved in pharmaceuticals, food processing, and then more broadly into manufacturing. So broad range of industries that rely in one way or another on heat as part of their process, and therefore are impacted by a change in the ambient temperature, and more particularly in terms of the heat extremes that occur at certain times of year. And this can be critical to their safety, their performance, and their productivity. So many of these industries, I must stress, that we looked at are in the process of transitioning also from being relatively high carbon industries through to much more low carbon industries as we work towards establishing a net zero future. So these industries will be around for a long period time to come, and will need to adapt in the decades ahead. So thinking about safety, performance, and productivity, which was the nub of the report, in particular performance and productivity, but we must emphasize, of course, there are considerable examples within these sort of plants and equipment and facilities of safety implications from the overheating of electrical equipment that could lead to fires. And indeed, that's a real issue in buildings as well. And there have been many examples of electrical equipment overheating in heat waves and leading to substantial fires. Not only the equipment, though, but also materials and waste can auto-ignite when temperatures get very high. So providing yet another safety hazard. So we need to think very carefully about the positioning of materials and the insulation of materials during hot periods of weather. Of course, many of these industries use pressure vessels or vessels containing fluids or materials that when become hot need to release pressure into the environment and become over-pressurized. And of course, indeed, some of these releases can be of hot gases, which can lead to other safety issues for plant and equipment surrounding the point of emission. But also, of course, they can increase the environmental impact of the plant, both in terms of general pollution and odor, but of course in terms of greenhouse gases as well. And then, of course, as we would expect, expansion and stress of pipe work and fittings. And there's a lot of work that needs to be done in this area in terms of addressing these within the regulatory environment. And the Environment Agency here in the UK is looking into that quite strongly. But the main focus of our work was really around the performance of the plants. And for example, a key area that we looked at was in the performance of cooling, because cooling is a key element of most of these processes. At some stage within the process, there's a heating activity and a subsequent cooling activity, or a cooling activity right from the start. And as the ambient temperature goes up, the performance of the equipment decreases. And as the peaks occur in heat waves, then there's significant degradation. And this leads to, if we need to address this through adaptation in terms of engineering design, this can lead to an increase in the size of the plant and the cost implications of that, as well as the broader implications of that in terms of the footprint of the plant. Now, the cost side involves both capital cost because the size of the plant increases, but also the energy consumption of the plant goes up. Now, this highlights a real key point in our findings from the work, in that many engineers intuitively say, well, or lay people indeed intuitively say, well, we're already designing a plant to work at high temperatures in other parts of the world. Why can't we just take those designs and apply them in areas that are going to increase to similar temperatures? There are two aspects to that. One is this issue of increased costs, which will impact on the core business model for the facility under consideration to be adapted. And this involves a whole range of economic issues associated with that particular geography, jurisdiction, in terms of different labor costs, material costs, equipment costs, environmental protection costs, etc. But also the increase in the footprint can be quite challenging in areas where there are high pressures on land, particularly, for example, in mature developed economies of the Northern Hemisphere. So it's not that simple. And then the other aspect is that the design envelope for the plant can increase quite dramatically from very high temperatures in the plus 40s and 50s down still to sub-zero temperatures in the minuses, due to the fact that we still will have to deal with the occasional very cold winter in the Northern Hemisphere for some time. And of course, there's also a performance issue when we are thinking about transitioning to net zero technologies, for example, carbon capture and storage and utilization and direct air carbon capture. You know, a lot of net zero technologies that we're relying on for the future need to be designed now to take into account these changes in ambient and extreme temperatures. And coming on to Ruth's area with the extreme heat impacts on industrial buildings, we looked at both buildings that exist and the design of new builds and the associated infrastructure that supplies the buildings. And one of the key aspects of industrial buildings is that they're characterized by high internal heat loads because of all the processing and industrial activity going on within them. And they're susceptible to external temperatures simultaneously. So often the construction materials and the color are not conducive to natural cooling, so passive cooling of the building. They often lack internal ceilings and insulation and external shading, all aspects of building design that would help manage heat within the building without having to resort to mechanical cooling technologies. So they're not designed for prolonged high temperatures, often incapable of passively shedding heat. And this leads to the sort of discomfort levels that Laura was referring to earlier, with the consequent impact on productivity. Strain on the mechanical systems. We've already talked about electrical fires, and of course mechanical systems can overheat as well, leading to fires or jamming of plant in terms of mechanical conveyor belts, etc. And of course, damage to sensitive equipment such as process control and instrumentation and control systems. This all impacts on the productivity and financial health of the business. And there's some numbers there to give an indication of the sort of number of non-domestic buildings just here in England and Wales, and the significant challenge that we face in terms of dealing with the existing building stock and their power consumption during periods of hot weather. So we haven't got time within this webinar to go through all the report in detail. It's quite a substantial report. There's a huge amount of detail in there around what sort of challenges engineers and the engineering profession broadly face as a result of these increasing ambient temperatures and heat extremes, and a lot of information on how we responded. And one significant error in the report that John Dora contributed to was the engineering standards, design codes and building codes section, where the key challenge here is that industrial assets and buildings that we're designing today, right now, this afternoon, will experience considerable changes to climate during their lifetime, particularly in terms of, from our perspective, in terms of this report, particularly in terms of heat. And the challenge we have is that the approach adopted in many of these codes and standards really look backwards in terms of their consideration of weather parameters for climate. So they look at historical weather data when they're trying to establish climate parameters for the future to be used in design codes. So, what are the maximum temperatures going to be? What are the design temperatures, and what sort of safety factors do we have to include? These all use past data for the future. Now, there is a process underway to update a lot of these standards and codes, but it's a very lengthy and complex process, quite rightly, and requires a huge amount of work. So in the meantime, we as engineers have to work on designs to the best of our engineering ability that looks to future climate projections for the geographical area and the code jurisdiction that we work within, and look to develop those designs as best we can. Now, John will be able to say a lot more about that during the panel discussion. But along the way, clearly there are opportunities when we're retrofitting to, and when there has been damage to buildings, to build back better with climate change and future heat impacts in mind, rather than building like for like. And I'm sure John will give us some thoughts on ways in which we can deal with the uncertainty in the future temperatures that buildings will be exposed to, in particular using an adaptation pathways approach, which looks at decision points over time, keeping options open. As I said, a lot of the report focused on the issue of cooling, and this is really because so much cooling is used within these industries, but also because cooling is a significant contributor to climate change. And the sort of conundrum, the real challenge here is that whilst being a considerable contributor to climate change, we also need it to adapt to the higher temperatures. So we're going to need more cooling, not less. And this potentially leads to a vicious cycle of needing more cooling to adapt to higher temperatures, therefore increasing greenhouse gas emissions even higher, and then having to do even more cooling. So we need to move forward with a much more sustainable and net zero approach to cooling. And the report explores this in considerable detail and looks at new ways of thinking around cooling that involve a number of different approaches. And for example, we should always start with reducing the demand for cooling in the first place. So we need to think about how we change the way we interact with processes, and there's a lot of behavioral change in there, as well as process change, and the use of passive cooling. I already talked about the challenge with industrial buildings in that regard. We need to think a lot more about aggregating demand for cooling across sites, rather than dealing with individual cooling needs as discrete point solutions. We need to look to the broader site and beyond the site for natural heat sinks that we can use, renewable sources of cooling, and waste resources. For example, we give a case study in the report around LNG regasification, leading to a lot of waste coal that is currently not used, and how we might be able to use that on adjacent sites. We need substantial improvements in energy efficiency, of course, and we need to transition to new forms of refrigeration, because most of these cooling systems use refrigeration that has high global warming potential when they leak. And we need to, of course, in the much broader context, to think about life cycle analysis and a circular economy approach to think about much broader sustainability issues. So really, it's about taking a whole systems approach for a site and thinking thermally, rather than just reaching for electrons and current cooling systems. And finally, there's a significant need for us to update our knowledge training in terms of knowledge transfer in terms of education and training. Current systems, as Carola will be able to testified to, a design for a climate stable, cooler world, a much more benign world in terms of change. And it's now essential at all levels that we take climate change, and from our perspective here in this webinar, future heat impacts into account, and develop the skills for meeting those challenges in this warmer world. And this includes obviously understanding about adaptation and adaptation approaches, broader sustainability, how to build capacity for resilience in infrastructure, industries and communities. And of course, absolutely essentially, how we can do all of that once we transition to net zero, so not making the problem worse, as we've just discussed in cooling. There's a need for curricular and accreditation criteria from organizations like ourselves, the IMechE, to change, to meet this challenge. And we need different types of engineers. These challenges will require a new skill set. Adaptation is often place-based, community-based, very specific to sectors, as well as there being large-scale cross-cutting themes. And we need people who are very creative, innovative, can work collaboratively, are resilient and socially adept, and absolutely essential that they have excellent communication skills to be able to bring sectors, governments, and communities along with us. So these education and training skills need to also be more accessible, so much more relevant and responsive to a much more diverse range of people that we as the engineering profession have traditionally not looked to recruit into our ranks. So I'm going to hand over to Laura now, who's going to just run through the recommendations from the report before we move into the Q&A session. Thank you, Laura.
Thank you, Tim. So the full details of all the recommendations can be found in the report, but in short, we've split them across 4 different key audiences. So this first set of recommendations is really aimed at industry and emphasises the need for organisations to develop and implement adaptation plans for their people, buildings, equipment and plants, and importantly, invest in increasing their capacity for resilience. So how do they go about this? It's important that employers and employees co-design strategies for dealing with heat stress together, with support from national health and safety agencies. So in the UK, that would be HSE. It's important to note that these would also need to be tailored to specific needs of different categories of workers. So how much PPE they have, or what gender perhaps, and their age. It's important that we create an enabling environment in which teams can develop innovative and timely adaptation solutions, and encourage staff and employment and teams to develop standards and work with standard writing bodies to account for a warmer world, and in developing new ones for adaptation and resilience. It's also, we think, important to implement a strategy of build back better rather than like for like approaches to replacing aged and damaged buildings and assets to ensure that they're really fit for future service in a hotter world. Next slide, please, Tim. Thank you. The second set are aimed really at policymakers and emphasise the need to recognise the potential productivity impacts of higher ambient temperatures and heat extremes on industries, which underpin their national and local economic well-being and really help to support them to adapt. So one of the first things we think is really important here is raising awareness of heat-related impacts and the need to take urgent action on adaptation, and raising awareness amongst industrial asset owners and building owners, developers, but also financiers and lenders. There also needs to be planning policy that reduces the risk of exposure to climate-induced heat impacts, a review and update of building codes and regulations so that they are relevant to projected future climates, There needs to be national net zero strategies and investment decisions to address the threat from higher ambient temperatures to the performance of technologies and industries. We think there should be an energy policy vision for industrial cooling, which isn't constrained by defaulting to electricity, but utilizes available thermal sources and, like Tim said, thinking thermally. And finally, on this, really encouraging high hazarded industry regulators to mandate operator assessments of extreme heat risks and other climate threats within their license to operate application, as well as encouraging them to carry out a gap analysis between the original design specifications and more recent climate data and more recent future climate data and projected climate data. And next slide, please. The third set of recommendations are really aimed at the engineering profession. So engineers will be key in achieving a society that is well adapted for to future climate change and should help industry prepare for the potential impacts of increased temperatures. So really encouraging engineers and to offer their time and expertise to standards writing bodies, and recognizing that a simple transfer of design and operational practices from already hot countries is not necessarily a viable adaptation solution due to differences in economies. So, for example, cost of energy, labor, materials, land use, and greenhouse gas emission policies. And also, alongside that, environmental and workplace regulations impact the viability of different commercial building models. Thirdly, there's devise and develop and implement innovative adaptation solutions based on net zero emissions, sustainability, and the circular economy. And then finally, taking a holistic system of systems approach to industrial adaptation, really considering those critical interdependencies. Next. Oh, thanks, Tim. The final set of recommendations is aimed at academia, and in particular the need to recognise, like Tim said, that current technical training and education provision was designed on the assumption that we'd have a climate stable future. So one of the first things we think is really important here is ensuring basic climate change knowledge is taught at every level, and making sure curricula consider approaches to adaptation and the principle of net zero design. I think it's really important to provide an accessible engineering education and skills training, which is relevant, responsive, and transformative, to attract a diverse range of people within non-traditional academic profiles. This also includes upskilling and some of the continuous development, which is an essential part in making sure that we have talent mobility between businesses, academia, and other organisations, both in the public and private sector. And then finally, really started to equip our engineers with the skills to work collaboratively. And Tim, back to you.
Thank you very much, Laura. So that brings to an end the presentation part of the webinar. I'm going to now move to stop sharing my screen. I hope that's stopped sharing, and move to the panel discussion. So would the panel like to switch on their cameras and join us? Thank you. So I just wanted to start off by offering an opportunity for Carola, John, and Ruth to add any comments that they feel that need to be added to the very brief and quick summary that Laura and I were able to provide. Before we dive into questions from the audience, I'd like to know from each of you what you consider to be any of the key burning issues, challenges, or responses that I didn't have time to cover. And I'll start with John. Would you like to say a few words about engineering design and standards and codes?
Thanks, Tim. I think the big one for me in the field of standards, and I've worked in ISO international standards for a while. At one stage, I was a Network Rail standards manager 20 years ago, and the thing for me is that we've got a climate that's different to what our standards say. So I think a strong message I would give to people is that if you're designing something, look at future climate, future weather patterns, and incorporate the loadings that come from the future weather patterns in your designs. You'd still be compliant with existing standards, but do look at the future, because the existing standards, like you said, Tim, are anchored in the past.
Thank you, John. Ruth, do you have anything to add to the industrial buildings section?
Absolutely. I guess to build on what John is saying, for the majority of my career, I work on new buildings. As engineers, we spend a lot of our time designing buildings that are about to be built. And a lot of those buildings actually do consider climate change and go beyond the standards. But when I look at climate change resilience, which is the real focus of this report, we're looking at an incredible wealth of existing buildings. And I think that's a real challenge for the industrial industry and for the construction industry of how do we understand the performance of these buildings, how are they going to behave going into the future, and how are we going to adapt them. So I think there's a huge body of work to be done to go in to audit these buildings, to look at the fabric of these buildings, to look at the ventilation systems of these buildings, to look at the mechanical plant of these buildings and say, is it fit for the future? Is it going to perform well if we have more heat waves like we did last summer? How are these buildings going to work for us as we move forward in a changing climate? And I think that's it's a huge amount of effort that's going to be needed there.
Okay, thank you, Ruth. And then finally, Carola, would you like to say a few words that maybe I didn't have time to expand on that you felt needed to be said before we dive into the Q questions?
Thank you. I think it was quite well covered, but from my experience in education, I think there is a big focus at present on sustainability within education. We are focusing on CO2 reduction and net zero, but I think in terms of the adaptation, that is not really embedded yet in the awareness of our students, that those standards that they're using today for certain design works, that they will be changing quite quickly, and that they will have to adapt in their approaches earlier on. So I think in terms of the educational sector, we need to make our students aware what impact that will have on their professional work that they will be doing once they are leaving university. I mean, everybody is aware the temperatures are rising. Nobody can deny this, particularly after last summer. But how this actually then translates into the working career and the professional life of a young graduate, that is something where I think we need to do a bit more embedding, and where we can do maybe a little bit more in terms of accrediting engineering programs, such that this angle is well covered as well.
Thank you, Carola. Yeah, that was a really good point there. So I'm going to move into some of the Q&A parts of the webinar now. So I've got a number of questions, and I'm just going to take them as they come. So I've got a question based from somebody who says, I'm based in the UAE, where the summer dry bulb temperature can reach 50 degrees C for 3 to 4 hours during the middle of the day. So they say that the construction workforce adapts by starting early, 6 a.m., and taking a few hours off during the hottest time of the day. So they're suggesting that we need to think more flexibly, ways to work more flexibly in Europe, and indeed in the wider Northern Hemisphere as it gets warmer in the summers. And I just wanted to direct that initially to Laura. because this is quite relevant to your section of the report. So do you want to comment on that at all, Laura?
Yeah, I think that would be great. It would be great if it was as simple as that. And I think one of the biggest challenges is a cultural change. It takes a lot. It would need everyone changing their way of life, really. Even just closer to home, you think about Spain and where a lot of buildings have shutters on, or have that shade, have a lot of good trees and shading. We don't necessarily have that all ready to go in the UK. So it's about really, it would be great if it was that simple, but I think there's a huge host of other factors. Additionally, the costs and the availability and willingness of workforces to work maybe some unsociable hours. I think there's a whole host of complex issues. I think Ruth, you're looking like you.
I think you are correct. I mean, we see the idea of a siesta in a lot of actually Mediterranean climates. That's really commonplace across a lot of European cultures. Where climates are hotter, that idea of taking the afternoon off it's been around for millennia. But as you say, in the UK or in the Northern Hemisphere, it's just not been part of our culture. And I think for some industries, we may need to look to move to that, but that needs a wider societal shift, because our society in the UK, I mean, I have children, right? My society is geared around my children being in school or childcare in the middle of the day, and my work life is structured around that. And that's commonplace for most people in the Northern Hemisphere. So I completely agree. And I think there are great examples around the world of where that works, but it would require a much wider societal shift for that to be achieved in the UK, I think, and similar nations to the UK.
So Ruth, I'm interested in what you're saying there, and I think you're absolutely right. There needs to be quite a significant cultural shift within many of these industrial sectors. And of course, we did see some of that within the pandemic. The pandemic was a temporary short-term thing. I mean, it's still going on in many parts of the world. Of course, we want to recognize that. But in terms of a lot of countries who have largely been fully vaccinated and moved forward beyond the immediate impacts of the pandemic, we shifted very quickly back to our old cultures. And, a lot of what we learned during the pandemic in terms of behavioral change and cultural change just seems to have almost disappeared now. But of course, here we're dealing with something much more long-term and systemic. And so we have proof that we can change. It's just a question of needing the willingness and the confidence to do that. And do you think that's how do you react to that comment?
I think you're right. And I think there are two aspects to it here. One is, and we saw this during the pandemic, it created almost like a two-tier culture. So I do a job that I can predominantly do from anywhere. I come into the office because being in a team environment is very, very important. But effectively, I'm working on the computer that I'm working on today. So I could work from home very, very easily. The sort of buildings that we're talking about with industrial plants, the majority of those workers have to be physically on site to do their jobs.
Yeah.
And we saw that during the COVID pandemic. There were lots of people who had to go to work to be able to do their jobs. And for those workers, the pandemic perhaps didn't significantly change how they were working. It changed their PPE. It perhaps changed how close they were to their colleagues, but they still had to physically be on site to do their jobs. So it was actually maybe we're in a luxurious situation as a panelist that we have the sort of jobs where we can work remotely. And then my other thought on that is that in cultures where we have a siesta culture, or there's a stop in the middle of the day, people generally work close to where they live. And again, in the UK, I mean, a lot of people will commute up to an hour to get to their job. That sort of taking time out in the middle of the day doesn't really work if you're still having to stay within your work environment. Again, there are cultures where people sleep at their desks or their sleep environments. I think that happens more in the Far East. But again, that's quite a cultural shift. The idea of a siesta is you go home or you have leisure time or you spend time, you eat or you rest in your personal space, not in your work environment. So again, we have quite a culture in the UK of people traveling a long way. The pandemic did change that. A lot of people did move. But yeah, quite a cultural shift, I think.
Yeah, thank you. Thank you, Ruth. Yeah, really, really interesting. Carola, one last quick point on that, and then we'll move to the next question.
Yeah, I just wanted to add on. I was also thinking about the siestas in countries like Spain or Greece, for example. And I think what happened as a result of energy being available, there has been a shift in those countries that they continue working through the hottest periods of the day because air conditioning made it possible. And I think it's changing the culture back to their original ways of working in order to be able to work in a more sustainable way.
Okay, thank you. So the next question relates to standards, and probably Ruth and John would be most interested in answering this. So standards and existing guides from the likes of CEBSI and ASHRAE are all based on hindcast data. So we have sort of mentioned that during the course of the presentation today. And while engineers can use future climate modelling here in the UK from the Met Office, of course, UK CP 18 or such like, isn't it incumbent on the institutions to be key to driving the shift from using historic to future data? So, John, I mean, you're a fellow of the Institution of Civil Engineers. Ruth, a fellow of this institution. What is your reaction to that question? Starting with John.
Yeah, I think that's right. The engineering institutions need to take a lead in this area and sort of get into things like taught courses at universities and beyond, and have some policy statements in this area. I think there are some good sort of statements around, but it's a bit difficult to find them. But it's something that needs to be done. We need to look at the future. We need also to design for the future. And of course, the other thing to think of there is that it's like I think Ruth said, the new infrastructure, it's easy to design new infrastructure. It's what's out there that's a big problem. But the other thing I've done in a chat with Spence from the Environment Agency, I popped in a link to some tailored guidance for standards writers, which shows standards writers how to modify their standards for the future climate. And I hope that's helpful as well. Thank you, Tim.
Thank you, Ruth. From the Institution of Mechanical Engineers, what's your reaction to that?
I do think it's incumbent on institutions. When the UK CP09 climate change data came out, which was quite a number of years ago, it came out with something like 10,000 future scenarios. So they had this incredible wealth of data. And when we think of the UK CIP work that's done, it's intended to inform all industry, all infrastructure, all policy making. It's not tailored to the construction industry or to the process industry. It's there for everybody to use. And at the time, I was working with CEBSI actually, and they did their climate change projections based on the UK CIP09 projections. And the UK CIP09 people we spoke to had no awareness, because it's not their industry, that an architect or an engineer working in the construction industry wouldn't willingly run 10,000 simulations, and that wasn't normal for our industry. And of course they don't. There's no reason why they would understand that. So it's incumbent on the institutions looking after the particular industries to provide what those industries require, be the IMechE or CEBSI in this case, looking at the process industry or construction respectfully, because it's our role to take what UK CIP has done, which is incredible, and distill it down in a way that's genuinely usable in an efficient, quick, economically viable way for the industries that we work in. Yeah.
Okay. Thank you very much for that, Ruth. And I think Laura can testify to the fact that we are, as an institution now, trying to engage, or are indeed engaging strongly with the Met Office around this issue, and looking at how we as an institution might be able to help solve this challenge. So more of that later. Carola, I have a question probably to start with you. Young people are more exposed to being educated around the impacts and challenges of climate change, obviously through further and higher education journeys. How can we have a similar impact on the older generation, people like myself, who are at the very other end of the spectrum, to make a change? How, you know, where is the opportunity to make a similar change to the older engineers? You know, and indeed, of course, you know, engineers are working longer into their life as a result of you know, the sort of workplace challenges of not having enough skilled engineers available.
I mean, I think targeted CPD training is the way forward here. As engineers, we are always trying to be updated with newest development, and I think having maybe a targeted program to embed this in certain training programs is the way forward. And one of those things is, for example, this webinar that we are running at the moment is trying to send out the message to the currently practicing engineers as well, to have this on the radar.
Mm-hmm. Okay, thank you. Laura, did you want to add anything to that?
Yeah, just to say, I think it's the role of institutions like IMechE, where a big thing of ours is actually the lifelong learning of engineers. So providing those opportunities for engineers at all levels to train and maybe retrain, maybe learn new skills, new information, and things like Carola said, this sort of webinar and this report and other events that we're doing around it really help get that message out there and give people the opportunity to learn and retrain.
Thank you, Laura. So quite a specific question here, but I think it's useful to you know, to sort of focus our minds on the sort of practicality of this topic or this issue that we're discussing in regard to the last question. So the question is, I lecture on food factory design to the food and drink degree apprentices. What do you think I should include in the curriculum of teaching that would advise that meets the criteria you have mentioned here today? So your views would be really useful. So let's start with Ruth on that. Ruth, you know, thinking about food and drink factories, food factories, industrial buildings, what sort of things do you think ought to be built into a curricula teaching young engineers who might go into that sector?
That's a great question. So I would say I don't know what food and drink apprentices are currently taught. It'd be quite an interesting thing to know about. I think with all industries, I mean, I'm obviously an advocate of the construction industry, and one of the reasons I'm an advocate is because every single thing we do involves a building, pretty much. So an awareness of the building that you will be operating these factories within, or your processing plants within, I think is something that should be included in that sort of degree apprentice course. An understanding of how the design of your building affects your ability to achieve what you want to achieve. And we know with food in particular, in the fluids and thermodynamics of food, that temperature is absolutely critical. All of us cook. Food is inherent in all of our day-to-day lives. So you don't have to be an expert in food and drink to understand the impact that temperature has and humidity has. So helping your apprentices to understand just the fundamentals of building design, of the fluids and thermodynamics of air and humidity, alongside the fluids and thermodynamics of the food and the heating and the baking, and the setting that you're probably already teaching them, I think would be a really valuable and quite relevant. It's all fluids and thermodynamics when it comes down to it. Everything we're talking about here really is how we are moving heat around, how we're moving air around to achieve the output that we want to achieve.
Thank you, Ruth. Did you want to add anything to that, Carola or John?
I think
it's begin, Tim. It's just I'm thinking, you know, I'm not an expert in food factory design, but one of the crucial things from a sort of structural engineering point of view is what's the design life, what's the expected life of the factory, and if it's up to 10 years, you might not have to worry too much. But if it's over 10, 20 years and beyond, then the climate is going to, well, the climate is already changing rapidly, but the climate is going to change markedly over a longer lifetime and affect longer life cycle assets. So that's something to factor in. That's one thing. The second thing was that part of my role at the University of Birmingham as a visiting professor is to look at the taught material to see how it incorporates climate change. And I like to do things like look at the top level of governance and mention the phrase climate change, and make sure that subject is looked at by everybody involved in devising top material, so they can decide then whether it's relevant or not.
Okay, thank you, John. And Carola, I think you wanted to say something there.
I think it's been largely covered, but I think, again, if these students also have the awareness of climate changing, if they are working, for example, in the fruit production and need maybe to replace cooling equipment, it's this thought process not to replace like for like, but thinking ahead in terms of a changing climate and the capacities that might be needed for a specific plant in the future.
Okay, thank you, Carola. There's a question here that I think I can just deal with quite quickly. So, did you look at the nuclear power industry, as elevated temperatures could have significant impact on the provision of cooling to safety critical equipment? And the answer there is yes. As part of the exercise of soliciting contributions from a wide range of engineers from across a lot of sectors, we did have input from members in the nuclear power sector. Although the report doesn't specifically focus in particular on nuclear power, the input that we got was spread across the report amongst all the various sections. So the thinking is certainly there, and the recognition of that is certainly there. So I got quite a few specific questions here, but I just want to tackle one about the IPCC work. The latest IPCC report emphasizes adaptation limits, points beyond which risk is intolerable and cannot be managed. Some of those limits have already been reached, the IPCC tells us. So John, this is sort of a question for you, really. How do we deal with that? How do we deal with adaptation limits? So I think here we're talking about thresholds, aren't we? So would you like to say a word about that, John?
Yeah, just succinctly, we don't always understand the thresholds to which our systems work or operate efficiently. We don't always understand when they start to fall over. So one of the things is to understand those thresholds. And I know, working in the railway industry for quite a number of years, we were quite surprised to find out the railway tends to be reliable up until, I think, an air temperature of about 24 degrees, when certain things start to fall over. So an understanding of system behavior is crucial there. And then to build into that, something like an adaptation pathways approach, which you mentioned in the report, Tim, and there's BS 8631. 8631 is a standard on dealing with uncertainty using adaptation pathways, which is a useful tool, I think, in this space.
Okay, thank you, John. Thanks. Okay, so question for Laura, quite specifically. Did the report provide any recommendations to the HSE, so that's the UK's Health and Safety Executive, on including a maximum workplace temperature, which would, as a consequence, drive changes in industry? And if not, why not? So Laura, I know you did a bit of work on that. Could you share that with us, please?
Yeah. So we didn't specifically recommend us setting an upper temperature limit, and that's because it really does vary on the industry, the type of work you're doing, the type of person you are. So what we've said is actually organisations like HSE should be working with industry and employers to really work out what appropriate temperatures are for that workplace and put in place suitable administrative measures to support their workers. So whether that's regular hydration breaks or even mandatory hydration breaks and things like that, those measures should be worked out with employers and their employees with the support of HSE, is where it landed.
Okay, thank you, Laura. So I'm very conscious of time. We have very little time left, and we've got a huge number of questions, which I think will have to be looked at a later stage. So what I want to do now is just offer a quick opportunity to go around the panel and ask for any final comments before we close. So starting with Carola, do you have a final comment before we close? Laura, what's the number one issue takeaway that you would like people to have from this webinar? You're on mute, Carola.
Sorry, I think it's working with the institution, trying to update the requirements on university curricula, such that we are embedding that firmly in the development of our young engineers. I think that's probably my key direction for the future.
Thank you, Carola. Nice and succinct and very much focused. Thank you. Ruth, similarly, something nice and succinct.
I think for me, I'm just hoping that the report and the webinar have really just raised everyone's awareness of the impact that climate change is having on this industry. I think this is a topic I haven't seen tackled so specifically elsewhere. We do a lot of climate change work on residential buildings. We do a lot of climate change work on schools. I, in my work, haven't seen it applied to this industry before. So I'm hoping that for everyone who's joined us today, it's really helped your awareness.
Thank you, Ruth. John?
I just think, a bit like Ruth, I think this is a great capacity building exercise, spreading this message. I think you said, Tim, there's over 200 people
Yes.
listening to this just now, and I think that's really great. And it's a case that, if you can spread that word further, if each one of you speaks to 2 people, gets it out there, the message is out there, the tools are there. We need to work and make things more resilient.
Thank you, John. And last but not least, Laura.
I'll just echo what everyone said, really. I think the raised awareness of adaptation specifically, I think it's really important that we consider both adaptation alongside mitigation. I heard it described as being 2 sides of the same coin before, and I think that's a really great analogy of what we're doing here.
Okay, so thank you, Laura. So just remains for me to thank you for attending this webinar today. And if you'd like to review any parts of the webinar at a future date, or indeed recommend it to your colleagues to watch at some future point, then it will be available in the webinar hub of the Institution of Mechanical Engineers website in due course. So thank you very much to our panel for joining us for a very stimulating conversation, and thank you to the audience for your time. Have a good afternoon, and goodbye.
Thank you, Tim.